Hi, let's look at a simple but interesting technique that you can use to remind yourself, like when it comes to differentiating as well as integrating trig functions. So the two trig functions that you're going to be using as basic functions, as I would call them, it's sine theta as well as cos theta. But you might say, well, there are other trig functions such as, let's say, tan theta, such as cosecant theta. We have secant theta. We also have a cotangent theta. So what it is that if you are really if you are familiar with trig identities, you know, or you remember to say you can write any of these in terms of sine or cos, or sine and cos altogether. Okay, so it's just a matter of you knowing what trig identity that you're able to use for you to differentiate or integrate any of these other four trig functions that we have here. Okay, so now let's look at how we can easily differentiate and integrate sine theta as well as cos theta. So the basic idea about this trick or method, as one would call it maybe, is if I write diff here for differentiating, okay, then I'll write that for integrating here. So what happens is that when it comes to this, how do you differentiate and how do you integrate? Okay, so what it is that if you're moving in a counterclockwise direction, you are differentiating. If you're moving in a clockwise direction, you are integrating. So remember to say the derivative of sine theta is cos theta. The derivative of cos theta is minus sine theta. The derivative of minus sine theta is minus cos theta, which makes a lot of sense because if I say uh, if you have sine theta, okay, then you differentiate it, you're going to get cos theta. But because of the negative that you have here, this also turns out to be what? To be negative. Um, Turns out to be negative there, which is this negative that you have right here. Okay, it's that simple. And you find that again, the derivative of minus cos theta is going to take you back to what? To sine theta. It's simply because the derivative of cos on its own is minus sine. So you have like a minus times a minus giving you positive sine. And that's what we have right there. So we have observed to say if you move in a counterclockwise direction, you are differentiating. So let's look at integrating. If you integrate cos theta, you're going to get sine theta. If you integrate sine theta, you're going to get minus cos theta, and it just keeps on going, just like that. So the same applies to, let's say for example, you are given a trig function. Let's say tan theta. You know to say tan theta can be written as it can be written as that is sine theta divide by what? Divide by cos theta. If you are to differentiate tan theta, you can either use chain rule or quotient rule. But regardless of whatever method that you are going to use for this part here, it all requires that you differentiate sine and cos at some point. Okay, so it takes you back to this part again. So you just have to remember to say counterclockwise differentiating and clockwise is for integration, and it is that simple and straightforward. Okay, so you can apply it on other trig functions as well, as we have also shown for for tan theta. You can bring in the cosecant theta, the secant theta, the cotangent theta. You can just write them according to like their equivalent trig identities in terms of cos, or in terms of sine, or in terms of both sine and theta, as we have seen for tan theta there. So that's all in this video. Thank you very much for watching.